Olá pessoal, então para quem não me conhece, eu sou o Leandro Garbim, deixa eu só abrir aqui um pouquinho aqui a minha tela para vocês me conhecerem. Eu sou o responsável comercial aqui pela VirtualKai, então eu só vou passar uma breve apresentação sobre a VirtualKai para vocês conhecerem um pouquinho melhor aquilo que a gente faz. E depois eu vou passar a palavra para o Ruth Salomon, tá? Ele é o responsável técnico comercial do KULI, ele que trabalha junto lá com o pessoal da ECS, da Engineering Center Steyr, que fica na cidade de São Valentim, lá na Áustria. Então vamos lá, deixa eu mostrar um pouquinho sobre a VirtualKai. Então nós temos a missão de oferecer softwares, a gente tem a missão de oferecer softwares e serviços de KAI com profissionalismo, comprometimento, preservando sempre a confidencialidade dos nossos clientes. Tudo que eu vou mostrar, todas as apresentações, todos os casos de sucesso, nós temos extrema confidencialidade com nossos clientes, nós temos autorização para isso. Nós atuamos no mercado latino-americano desde janeiro de 2006. Atualmente nós temos uma referência algo em torno de 40 clientes. Nós representamos soluções específicas para a área de simulação de produto, ok? E também atuamos na comercialização, na prestação de suporte técnico e desenvolvimento de software. Eu vou falar sobre um software específico, que é o VirtualPython, que ele é totalmente desenvolvido por nós aqui na VirtualKai. Nós já realizamos algo em torno de 100 projetos, né, principalmente para a indústria automotiva, é o nosso grande foco, são os nossos maiores clientes, são todos na área automotiva. A gente gosta muito aqui de universidade, pessoal. Tá? Nós temos uma parceria muito legal com todas essas universidades, com ITA, Unicamp, Escola Politécnica da USP, Unifei lá de Itajubá, Universidade Federal do Rio Grande do Sul, a FEI, a Mauá, entre outras. Atualmente nós temos relacionamento com algo em torno de 25 a 30 universidades do Brasil todo e também fora, na Colômbia e na Venezuela. E atualmente também a gente também realiza treinamentos tanto teórico quanto de aplicação nas ferramentas que eu vou mostrar para os senhores agora. Então essas são as nossas tecnologias, tá? Nós trabalhamos com cálculo estrutural, otimização estrutural, que é a ferramenta que nós desenvolvemos aqui na VirtualKai, análise de fadiga, impacto e segurança, dinâmica veicular e controle térmico. Ok? Controle térmico vai ser o objetivo de hoje, é a apresentação do software KULI para os senhores. Então vamos lá. Na parte de cálculo estrutural, nós representamos a ANSYS juntamente com a E3S. Então, o ANSYS é um software de cálculo estrutural, ele tem um pré-pós-processador integrado, a interface dele é super amigável, tem interação com praticamente todos os CADs do mercado, e ele é um solver muito robusto, muito capaz, que é possível de realizar análises não só estáticas, lineares, não lineares, termomecânicas e dinâmicas, e é um software mais conhecido no mercado, ele é o líder mundial nessa área de cálculo estrutural. Falando rapidamente sobre o VirtualPython, o VirtualPython é um software desenvolvido por nós aqui no Brasil, pela VirtualKai, nessa área de otimização topológica, que o objetivo é a redução de peso, redução de massa de componente, a otimização MacFlex, mecanismos flexíveis. Nós consideramos que nós somos a única ferramenta capaz de realizar mecanismos flexíveis, você consegue dar inteligência para o seu mecanismo. Otimização de frequência, otimização com restrição de tensão, stress constraint é uma coisa que a gente trabalha bastante, diversas condições de manufatura, atualmente nós temos 26 condições de manufatura, restrição de manufatura, otimização e análises não lineares e atualmente ele tem interação com os solvers ANSYS, Abacus e nós estamos acabando a interação com o solver da MSC, o Nastran. O FEIFAT é um software voltado para análise de fadiga, ele também é da Magna Powertrain, então ele tem a prevenção de falhas por fadiga, ele contempla diversos tipos de análise de fadiga, fadiga alto ciclo, fadiga baixo ciclo, fadiga com eixo de excitação e até mesmo nos 6 eixos de excitação, que seria fadiga multiaxial, fadiga em solda, tanto a ponto quanto a cordão, e fadiga térmica. O interessante é que a gente tem uma experiência aqui muito grande de rodar cálculo estrutural, otimização e fadiga no mesmo loop. Análise de impacto, nós trabalhamos com o ANSYS LS Dyna, ele também é o líder mundial nessa área, ele também é um solver e também um pré-pós-processador. Ele realiza análises tanto implícitas quanto explícitas, então são impacto. Impacto seria eventos de curta duração no domínio do tempo, análise de impacto e segurança veicular, como ROPS. ROPS é uma das análises que a gente faz bastante aqui, que seria Rollover Protector Structure, que é tombamento de trator, tombamento de ônibus, é uma coisa que a gente faz bastante por aqui também. Análise de drop test, queda livre de celular, queda livre de algum outro componente eletrônico ou não. Análise de conformação mecânica, tanto estampagem quanto forjamento, o LS Dyna consegue fazer, e ele é o líder mundial para esse tipo de análise, que são análises de impacto. A análise de dinâmica veicular, nós somos representantes aqui no Brasil de um professor chamado professor Thomas Gillespie, ele é da Universidade de Michigan, e esse professor fundou a Mechanical Simulation Corporation, que fica na cidade de Ann Arbor, lá nos Estados Unidos, e ele é um software bastante intuitivo e preciso e um custo bastante acessível. Eu estou falando tanto do CarSim, voltado para veículos de passeio, caminhões leves, utilitários, o Truck Sim, caminhões pesados, e a Bike Sim, motocicletas, scooters, e o Suspension Sim para modelamentos de suspensão. Todos esses têm uma vasta biblioteca de veículos de pista, uma excelente visualização de resultados, então são softwares bastante intuitivos voltados para essa área de dinâmica veicular. O KULI dispensa apresentações, o Rolf ele vai falar bastante aqui sobre o KULI, sobre essa parte de gerenciamento de temperatura, ele tem módulos específicos para HVAC, que seria essa parte de ar-condicionado, tanto o heating quanto o ar-condicionado, e arrefecimento. Ele simula tanto essa parte de compressor, radiador, condensador, ventilador e também o evaporador, e ele faz otimizações de parâmetros voltados para essa parte térmica. Então, esses são alguns dos nossos clientes, senhores. Atualmente, a MAN, a MAN e a Mercedes são os nossos dois grandes clientes nessa área de softwares. Nós fornecemos softwares para esse pessoal, não só as OEMs, como também as autopeças e também institutos de pesquisa e ensino e pesquisa. E também a gente presta serviço nessa área de engenharia. Então, a análise estrutural, tanto estática, linear, não linear, análise dinâmica, contato termoestrutural, fadiga, otimização estrutural com a possibilidade de combinação com a análise de fadiga, análise de multicorpos de dirigibilidade, tá? Powertrain, transmissão, sistemas de direção, chassi, suspensão, pneus e freios. A gente tem uma experiência muito legal nisso. E aqui são alguns dos nossos clientes. Tá? Atualmente, nessa área de serviços, a Cummins é o nosso maior cliente. Inclusive, o software que eu comentei para os senhores, que é o Virtual Parts, ele nasceu a partir das necessidades da Cummins. Então, nós temos uma interação muito grande com o pessoal de motores, que é o da Cummins, mas, entre outros, também nós são nossos grandes clientes. E quais são os seus desafios? Esse é o final da nossa apresentação. Eu deixo isso bem claro, que a gente gosta de trabalhar com análises complexas, com análises não lineares, com realmente uma engenharia bastante avançada que nós fazemos aqui na Virtual KAI. Ok, senhores? Então, essa é a minha apresentação. Agora eu gostaria de passar a palavra para o Rolf e volto a falar, caso alguém tenha alguma dúvida, caso alguém tenha algum questionamento, quer tirar alguma dúvida, comentário, por chat, o Murilo está inteiro à disposição. Murilo, você pode passar a tela lá para o Rolf agora? Hello, Rolf. Right now, my colleague over here, Murilo, just will transfer to you as a host, okay?
Thanks very much.
You can start your presentation, and I will turn off my camera. Please go ahead.
Okay, so thanks very much for the nice introduction. Sorry that I can't speak in Portuguese, but I hope you can understand my English. Can anybody hear me? And can you see my screen?
Yes, I can hear you, but I can't see your screen. You just need to you need to go to start. Go to start and share the screen.
Where it is, share my screen. Okay?
Yeah. Great, KULI. Great, Ruth. Right now is working. Please go ahead.
Okay, so fine. So I tried to give you a short introduction into the software KULI. It's only a short introduction, of course. When we have some time at the end, we can make a question and answer session, but maybe for a short introduction, it's enough. If you have any question, then of course you can ask afterwards me personally or Leandro for additional assistance. I want to give you a short overview, only 2 minutes, 2 slides, who we are. So we are part of the company Magna, which is the second biggest automotive supplier in the world nowadays. We are coming from this group Magna Powertrain, and my company, where I come from now, here is located in Austria. It's called Engineering Center Steyr, where we are dealing with complete vehicle engineering, with technology and software development. So we have heard about the 2 products, so 2 main products which we have, FEMFAT and KULI. And then of course we have some possibilities for vehicle testing here in our company. Our department, it's divided into 3 parts. So our leader is Christian for the whole department, and then we have 3 groups. So the one group which I'm leading is the sales group. I'm responsible for global sales, and of course then we have some assistance in different areas like Leandro for Brazil, for support and sales in Brazil. Then we have this 2 groups, software and services. Software it's Thomas, services is Christoph. And you see here that we have both groups under one umbrella, which give us good possibility to get the feedback from daily use from the users. So we have users in our department which are handling many projects worldwide. So we are now 25 years here in Austria, and there we have handled hundreds of projects for different customers. So for OEM, for suppliers, for engineering companies, and so on. So this gives you the possibility to ask not only software questions, which button I have put to push to get a result. You get modeling help for modeling questions and so on because of this experience of many projects. So let's speak about KULI. So that's a thermal management software. It's a Windows software, so it runs on a normal PC or laptop with very short calculation time. It's a 1D simulation tool with which you have the advantage to get very quick results in a very short time. So what we are handling is the complete powertrain cooling for conventional powertrains with combustion engines, as well as alternative powertrains with electric motors and so on, or a combination with a hybrid application. Additionally, of course, we can handle the air conditioning, so cooling down of the passenger cabin to get information how quick the cabin cools down when you start your engine after a long stay in the sun and you have 70 degrees in your cabin, and then you want to have 20 degrees after maybe 30 minutes or something like this. Of course, we can couple this because we have this one component, the condenser in the engine cooling path, which releases some heat and which has an additional pressure drop on the air side. What we are considering are all thermodynamic key values like temperatures, pressures, pressure drops at the different components, mass flow in different branches, heat flow or other energy flows. It's a Windows application, so with a normal Windows graphical user interface. So you see here at the top the component and functional bars where we can insert here with the command bar all the components in the system, or you can save in your library. Then we have this icon bar. With the icons you can insert all the different components in your system. You click only on the icon, then you choose one and insert into your system. Here on the left side, we have a project organization. So you can save maybe, as an example, some variants, and then you can skip very easy from one variant to the other to see what are the results for the different variants. Here in the big 2D window, we are configuring our system on the fluid network side. So fluid means we can handle, of course, charge air, we can handle different coolant types, we can handle oil, steam, and so on. So that's all here handled on the fluid side. That can be modeled very easy, like you see here, only the heat exchanger, and in the circuit symbol we are saving some starting values. So like which fluid we have inside this circuit, some mass flow, heat rejection, and so on. But of course, depending on the knowledge that you have in your different project steps, you can build up a more complex network with all the components on the fluid side. So branches, thermostatic valves, tubes, spans, and so on. So you can insert all the components that you have later on in the real application. Additionally, depending on the components that you have loaded, you see here in the 3D window the components on the air side to get an overview about the components that are on the air side. Like you see here, that's the radiator inlet grid. Then we have here maybe a condenser, charger cooler, radiator, then maybe 1 or 2 fan applications, and maybe a parallel air path to the passenger cabin with the heater here. So that's a normal setup of the application itself. KULI is divided into several modules to give each user the possibility to choose only that module that he is using for his applications. So KULI base, it's the base module for modeling coolant circuits for steady-state applications. So you can analyze some typical steady-state operating points, which are maybe critical for the layout or for configuring your system, and that can be handled here in the steady-state applications. Then we have additional modules like here, KULI Advanced. In KULI Advanced, we have some optimization possibilities which are built in them. So always when you model the first system, it's not the optimized system. So you want to look to the optimized system. So with KULI Advanced, you can set some targets which you want to reach, maybe the top house temperature, and then you have maybe some parameters like the volume flow on the air side or volume flow on the fluid side, maybe the size of the heat exchangers or the type of the heat exchangers that are your parameters, and then KULI automatically looks for the optimized solution. In this module is built in also a parameter variation. So with this you can make some parameter studies. So what if scenarios? What happens if I change one parameter in a certain range from a minimized to a maximum value with a specific step size? And so you can make this here in this parameter study. So that's built in KULI Advanced. There we have some possibilities to connect some other software tools, like when you want to make a co-simulation. So maybe with an Excel script. So with an Excel script, you can start KULI and then directly you get the results in the Excel table again. Or to MATLAB Simulink. Or if you have programmed some controllers in MATLAB Simulink, you can start KULI from MATLAB Simulink and then you get the results again in MATLAB Simulink. Or some other software tools that I mentioned here. Additionally, we have one for CFD analysis, for coupling with CFD tools. So KULI is a 1D tool, so we are normally calculating with an even airflow to some parts of the components. That's of course not the real truth. For this we have the CFD interface to couple with CFD tools to consider this uneven airflow to the heat exchangers on the air side. Of course, if you are coupling, then you lose the performance of KULI, so results in parts of seconds. if you have once started a CFD tool, you see that you are waiting, depending on the hardware, that you have hours or days on the results. So in some cases, we are doing this when we want maybe to optimize the shape of the fan shroud to get an even airflow to the heat exchanger frontal area. For this, of course, we can't do this in KULI because it's a one-day tool. For this purpose, you can use the CFD analysis. Then additionally, we can make some transient calculations. So you want to analyze the warming up or cooling down of your application with all the masses that are part of in your application itself. So what you can do then, you can specify a driving cycle, maybe or something like this, or some operating points at different time steps, and then KULI makes some transient analysis to see the warming up or cooling down behavior of your system. For this purpose, we have a special engine model. With this, automatically KULI finds the heat rejection to oil or to coolant depending on the operating point of the engine on your driving cycle. Then we have this KULI Eco module for e-mobility and recuperation. So what we can do there, we can build up a battery model to cool the battery and to see which heat release the battery has during your driving cycle or something like this. There we have integrated an electric motor, of course, the battery itself in different steps as a cell model or as a battery model, and then the power electronic components. In this KULI Eco module, additionally, we can make some recuperation studies, maybe with a Rankine cycle. So if you have some waste, you want to get some energy back from the waste, so from the where we can model some waste heat recuperation from your exhaust gas. That's what the word what I'm looking for. So that's possible here in KULI Eco. And then at the end we have KULI HVAC to model the complete AC system with all the components that are in the AC system. At the end, of course, we want to see in the passenger cabin the cooling down or heating up when you model the heating part of the HVAC system. I want to talk about some typical applications, of course, only some because the time is limited today. So one application can be to analyze the top tank temperature. So that's where we started 25 years ago. You have to insert some data for the fans and for the coolers, of course, maybe some volume flow data for the participating fluids. Of course, you want to analyze at specific ambient temperatures. Maybe you want to consider the driving velocity of your application and maybe the heat rejection from the condenser. And of course, you specify the amount of glycol in the coolant as well as other participating fluids itself. Then you model the system like you see here, very simple system, only the radiator, and here in the circuit symbol we have saved the initial information like volume flow at some specific operating points, the pressure inside the system at some specific operating points, and maybe the heat rejection for these operating points. Then you can make an optimization, so you can specify the target, which is allowed in maximum for your application. Maybe for passenger application, 100 degrees Celsius are allowed as a maximum value in your coolant circuit, or for truck applications, maybe 95 or 100 degrees as maximum value. And then you want to see as a parameter how much air has to go to the system to reach this value. For this, we have here a variable defined for the built-in resistance. As a result, of course, you get many values. I've shown here only a few of them. Of course, the top tank temperature, which we have specified here, is an optimization target. The air to boil, so up to which ambient temperature your system works. And then, of course, you can analyze different operating points of the fans, of the coolers in itself. And then, of course, you can make some additional parameter variations. to change the fan speed to see what happens if I change this, the volume flow for the participating fluids. You can change the type of the radiator and so on. And all this is possible. So that can be one application. An additional application can be that you want to make some concept studies. Here's an example to see what happens if I have a conventional charge air cooler or a water-cooled charge air cooler in this application. So you can build up very quickly this application, set up this system that lasts normally a few minutes, and then you make some calculations that are for steady-state operating point parts of seconds to get the results. And then you can see what you can do. So arrange the components in line or side by side. Use one high temperature radiator, one low temperature radiator maybe. Use water-cooled charge air coolers or something like this. And then you can make this many variants in a very short time. So at the end, you have one solution that fulfills your targets, and for this you build the prototypes, and then normally it fits your targets. So one application can be you want to minimize the package size. So we are always limited in the engine compartment in the size. So what we can do is we build up the system, and then we make a multi-parameter optimization. So we have one target that we want to reach for the coolant and one target that we want to reach for the charge air. As a parameter, we have the size of the two different coolers. So radiator on the one side, charge air cooler on the other side. And then now we make a multi-parameter optimization. At the end, we get the results with which minimize size our system works. And then, of course, we have to look with a supplier which he can produce, of course. So maybe you make a one final run with that produced that size that can be produced by your supplier. So an additional one can be that you want to make some transient simulation. So first you have figured out your critical steady state operating points. You have made some runs to see how big the components must be, and now you want to see if these components are working in the transient simulation too. So what information you have to add now additional? Some thermal capacities are now part of your simulation, so you have to add this information, so the mass of the engine block, mass of the fluid itself, the mass of the tubes, and so on. So all these you have to insert because they are now warmed up or cooled down depending on the temperature difference between the different components that are in contact now. So you model now these, and now you can make a transient simulation. So one additional application can be for AC simulation. You want to find out the evaporator heat load that the passenger cabin cool down requirements are met in a certain time. So you put your application in the sun. Now it's heated up, maybe up to 70 degrees Celsius when it lasts a long time in the sun itself. Then you start your engine and your AC system, and now it cools down in a certain time. Maybe you have measured some different temperatures to compare afterwards with the simulation in different zones. And this we can use now with a one-zone passenger cabin, so to get a first shot about the evaporator load. Later on, we have the possibility to work with a multi-zone passenger cabin, which is part of KULI too, to investigate the temperatures in the different zones. So in the head area, torso area, foot area for the driver, for the co-driver, and maybe for the front passengers. One additional application can be to make a hybrid simulation. So we have built up this car here in our company in hardware. So it was a conventional truck, and then we have added some components like an electric motor, a second coolant circuit, which has to cool down now the electric motor, the power electronics, and the battery. That was for this application was a separate one because we want to see what happens now. And then we have first made some calculations in KULI. What is the fuel saving? What can be the fuel saving potentials at different ambient temperatures? We have figured out around 10% at this driving cycle here, which we have used for these applications. And then we have looked, of course, at the different temperatures. For the coolant itself, we have to manage around 95 degrees Celsius. The battery normally feels well at 30 degrees temperature, so we have to manage this second temperature level, 30 degrees Celsius, because if we have too much variations of the temperature, the lifetime of the battery goes down very quickly. And then as a third temperature, we have to manage the temperature for electric motor and electronics at around 60 degrees Celsius. So you see here, the system is much more complex than for a conventional application. And so we have built up the system now with transient simulation, with adding all these additional components. And of course, in KULI, we have the possibility to find out these fuel-saving potentials depending on the different aggregates we have now additionally in our system. One application can be to take a closer look to the battery itself. So we want to manage that all cells have nearly the same temperature, because normally for a battery, it's allowed only that you have a difference from the coldest to the hottest temperature of around 3 Kelvin, something like this. So now we have to take a look at each cell here, which is built in the battery, and we want to manage to measure the temperatures at the different cells for a specific driving cycle. So that can be done in KULI in a very comfortable way, so we don't have to model cell by cell, because normally we have modules that are similar, and so you can build up the battery in a very quick way in KULI itself. But at the end, we get information about each cell separately. So when you think about the Tesla M model, there are built in about 6,000 different cells. If we want to model this part by part, you're working many hours or days maybe on this to connect each cell on the fluid side or on the air side and on the electric side, and then you have to connect the components, the cells to each other, because you have some heat transfer from one cell to the other cell when they are in the neighborhood and so on. So we have done this, but of course we found a better way to model only the battery, and we specify only how many cells we have in this battery and how they are located, if they are in parallel or if they're serial. And so then you can manage this modeling in a few minutes, then you are ready. But at the end, in the KULI post-processor, in our KULI lab, you get information about each cell then, and then automatically KULI shows you what's the coldest cell and what's the hottest cell itself. So there we are very flexible for hybrid applications or for electrical applications, electrical vehicles. So why we want to use KULI? So of course we have to take about emissions and fuel consumptions, because there are some legislations to reduce this. Of course we have, as a long time, we have this for passenger cars and trucks, but now we get this for agricultural applications too, and for commercial, for construction equipment. We have to manage the cost, of course, to reduce the cost. On the other side, we have our customers. They are sitting in our applications, and they want to have good comfort in the summer and in the winter time. So sometimes it's not easy to manage both because, of course, when we have an AC system, of course, we have to spend some fuel for this or some electric energy. Additionally, of course, we have to manage the durability of the components. So what I've told before, battery management, that's a big issue nowadays. We have seen that the engine power is increasing every day. So next generation of the engine has 10 or 15 horsepower more. And of course, with this, we get additional heat to our cooling system. Sometimes we have some crazy designers which very small inlet areas. We want to have always much airflow to our system because then we have the good possibility to cool down the components. So we have to manage this inlet area decreasing to some design issues. We have new technologies, of course, like hybrid applications, electrical vehicles, some recuperation, and so on. So we have to consider all these components. As we have started with the KULI development 27 years ago, we've started only with one radiator and one fan. Now we have hundreds of components in the system which we can insert and which we have in our library. And for this, of course, we have to manage all these more components and auxiliaries. So why we want to use computer simulation? Of course, when you think about the first step we have done, if you have one radiator and one fan, it's very easy to find the operating points of both components. But if we have more components like we have nowadays, we want to understand the complex component interactions now. And that we can only do in the computer simulation. And of course, each component has an effect on the other components, and we want to model this within measurement accuracy. I've told before that we can make many, very quick, many parameter studies. So what we are doing is kind of rapid prototyping, virtual rapid prototyping. At the end, we have seen when you have some experience, you have one virtual prototype, you build this in hardware, go on the test bench, and your system works. So that's always our target. And with this, of course, you can save much cost on the test bench or for producing some prototypes. When we are once on the test bench, we can support the test bench. So you can run in parallel the computer simulation with KULI, and then you can see if all the sensors are working correctly, because you know in which range the temperatures must be, and you can see if the sensors are working quite well. And of course, if you have once maybe some possibilities to improve the prototype, we can figure out which parameter to change makes the most sense. And with this, of course, you can make some optimization. You can quickly find measures for improvements. You can see which parameter makes the most sense to focus on that, because you can see in the sensitivity analysis which has the biggest influence on the results of the different components. If you have once a validated model and you want to make some update, maybe with the engine, you have some engine upgrade with some more horsepowers, you can see if your system is still working, or which changes you have to make. If you have to change some components, if you have make some components bigger or smaller. You can compare, of course, if you have different suppliers, the components of different suppliers very quickly. Yeah, let's speak about hardware demands. I've told before that it runs on every PC or laptop, can be an older one. So we have in our department some PCs that are 4 or 5 years old. It's no problem that KULI runs on this. So it works on any app, any laptop or PC. You get very quick results in parts of seconds for a steady state simulation. and of course for transient simulation lower than real time. You get very realistic results with low efforts, so the modeling time, it's a few minutes. And of course, it's very easy to learn. Normally, we are offering a 2 or 3 days training for our customers, and with this training, you are fit for use afterwards. So then you can model, of course, your complete systems only with this 2 days training. So it's very easy to learn. It's tailored to customer needs. So I told before that in our department are sitting engineers. They are working with the software. The software comes from engineers for engineers. I've told before this modular structure. So you can start maybe with KULI base for steady state simulation, and later on, if you see, okay, now I want to make some transient simulation, you can add on this module at any time, and then you buy or lease these additional software modules. We are working with some partners that can change, of course, during the development process. So we have partners here like Volkswagen and Audi and BMW from the passenger car side, MAN from truck side, John Deere that covers all the components and the applications for agricultural applications and construction equipments, then Porsche for sports cars. And then, of course, there are some companies for suppliers like Modin or Borgwana cooling systems where we are working together with this. So, and of course, then when we start a new development step, so we have one big release every year, we are asking always all our customers who wants to be part of our development group, and then we get some data of them for validation of our models that we have modeled. So at the end, we have, when we introduce a new version to our customers, we have validated models that are working for nearly all components that are on the market then later on. We are very flexible. If you have only an idea about some components, you can build up the system with a few data. Later on, if you have more information during your process of designing your components, you get more and more data you fill in the system up to a very complex system. Of course, you can take a look at the results in our KULI lab, that's our post-processor, where we get all the information about the different components, and for each component, of course, lots of information. We can filter these that you see only that information where you're interested in this project or so on. Of course, you can make some presentation material for your management with some colored slides and so on. We have a uniform component library, so all the components that are on the market you can build up in KULI. We have a media library where many oil types, water glycol mixtures, exhaust gas, refrigerants are part of this. But of course, you can extend by yourself, or we can extend for you if you have maybe a special oil type for some special application. We have a unit converter, so normally you don't have to take care about some units converting. So for the input data, you can choose the unit that you want to see. And again, for KULI Lab, you can choose other units or so on. You can make two different setups in KULI Lab. So one maybe for American customers with American units, maybe one for European or Brazilian customers with SI units. So both it's possible. You don't have to take care about the unit converting by yourself. We have built in this optimization package and parameter variation package to make very quick some iterations to find the optimized solution. We have some software interfaces like the most used are, of course, to Excel to start the simulation from Excel and get back the results to an Excel script, or MATLAB Simulink or some CFD codes. We have many customers worldwide, as you see here, so that's only a few of them. So of course, most of them in Eastern and Western Europe, because we are started here the sales process here, but we have many in Brazil too, which are working with own licenses or global licenses here in different fields of working. So you see here that we are working in the whole world for your advantage. In behind, it's a software support team, which you can reach by this email address here. And so what we can give to you is expertise through product overview. So that's what the sales guys have. They have an overview about all the software functions and so on. But additionally, we have the expertise through product insight, because we have the software development here in our department here in Austria. And of course, expertise through product practice, because we are working with our software by ourselves for different customers. In behind, it's a team of about 25 people. And of course, we are working for your advantage, and we give very quick response. So if you have a question to us, you usually get an answer, and that's our guarantee within 24 hours. So 24 hours later, you get help how to work with KULI and maybe how to model the different systems. Additionally, of course, if you have maybe not enough capacity for some urgent projects, we can give enhanced support to take over a complete project or to make some setup in your company or something like this. That's of course possible too. Who can use KULI? You have seen that we have a very wide range of applications. So passenger car, truck, buses, construction equipment, agricultural equipment, trains, but it's not restricted to automotive industry. So we have some customers which make the layouts of some gensets or something like this. We have customers at OEMs, at suppliers, at research companies or engineering services companies. And there are working design engineers or CAE engineers or test engineers. Sometimes it's one person which is covering all, depending, of course, on the size of the company itself. So when you can use KULI, of course, you can use KULI in different steps of your project. So in the concept phase, maybe you have the first ideas, you have only a few data, and you want to see how big the components must be. Later in the concept development, you get more and more data about the environment, about all the components that are in contact with your components and so on. You fill in more and more data up to the first prototype. Then you go on the test bench with your cooling system, maybe only. You get the first feedback, and then maybe you make some calibration of the system. And then you build in your cooling system in the car itself or in the application itself. Maybe you go on the test track, make some measurements, and then you have the product validation. So you can see we can work in the complete process of your product development. How we can use KULI? Let's speak about the data that we need. So of course we need some data from the suppliers. So that are the component data. So we are working normally with performance data of the different components. So maybe as one example for a heat exchanger, we have to read in, and we have to know, of course, the dimensions of the heater core, then the pressure loss on the fluid and on the air side, and the heat rejection map for one specific heater core. In KULI itself, we can change the dimensions, so we can make the heater core bigger and smaller. You ask only once the supplier for one specific set of data, and then you can work with this set of data for different projects. From the OEM itself, we need some data about the vehicle. So some design data, like how big is the inlet grid, how much pressure drop I have at the inlet grid, which components are part of the application, some data about the engine itself, which heat release you have at different operating points, and so on. That's vehicle data. Then you specify the simulation conditions, at which ambient temperature you want to calculate afterwards, which operating points you want to calculate, if it's steady state or transient simulating. And then at the end, you have to fulfill some boundaries and targets, like maximum dimensions of the component, maybe some maximum or minimum temperatures or pressure losses, all this. So that are the input data. So the first step is to collect all these data and insert in your library. Second step is that you have a principal idea how you want to connect the components on the fluid and on the air side. So you load the components from the database, you define the media properties for the different circuits, and then you position and connect the components. So that's, I would say, you have to spend some minutes for this, only minutes. And of course, then you insert the simulation parameters. Now you simulate, you run the analysis, some seconds or parts of seconds, and then you as the engineer want to find an optimized system, so you make some iterations. So maybe you vary some parameters, you change some components and so on to find the optimized solution. And at the end, you get an output in KULI Lab, in our post-processor, or in an Excel sheet or so on. And then you can compare your system with measurement data and you interpret the results and make your final reports for this. So that's a typical workflow here. In KULI Lab, you can analyze the data. You see here in this tree view, you see all the different components. Then you have the possibility to filter out some, for each component, that data that you want to see in the table here. Maybe 3 or 4 values for each component, for different operating points or different time steps with user-defined units. So again, here you can define the units that you want to see in the post-processor itself. We can make some additional diagrams, like you see here, operating point diagram for a radiator, operating point diagram for a fan, like you see here, or a radiator diagram that you see which different temperatures you have in which different areas of a radiator. And maybe here some bar charts or line charts for variant comparison. So normally you don't need any additional tool for analyzing all this different data. And here you see that we have additionally the possibility, when you have filtered out all the data, have made the diagrams, to export all these data in an Excel sheet, and then you can save this as an Excel file afterwards. Yeah, where you get KULI, you know, Leandro, there you have the direct contact in Brazil for leasing or for sales in Brazil. And of course, here from Austria, we are handling all the different second level support and all these, if you have special questions and all these. Yeah, that's all from my side. We have now maybe some additional time if you have some questions. Maybe Leandro, you can handle now the questions from the participants. Or of course, you are invited to send directly some questions to me. So here you see my email address, rolfsalomon@magna.com. That's possible. Of course, additional things you can find on our website. If you register on our website, you get some additional information, like additional examples from praxis that you can download. You can download a demo version of KULI there that you can install on your PC or laptop, and then you can get a first impression of KULI, how it works in real praxis. So that's all possible from our website. Please take a look on the website, kuli.at, to find out more information for the software itself. But now, of course, maybe we have some time for some questions and answers. Okay, Leandro, please.
Great, Rolf. I really appreciate your presentation. Congratulations for that. It was very good one. It's very simple. I think that the people just understand the KULI philosophy. Another point is that we are recording this presentation. We will include in our YouTube channel, and of course we will share between our customers over here in Brazil.